Right, I am really excited to do this lesson because it's something we've been meaning to do for a while. And basically, these are the mistakes you don't want to make in your HSC maths exam, right? That's a pretty negative way of talking about it. So at the title of your sheet, I've called it my favorite nose. Right? So, here we go. Now, why I love this, right, is because in maths, and just like in teaching in general, we usually tell you what you should be doing and how to go about things. And you guys are really good at listening to that, right? But a lot of the time, like when we tell you how to do things a certain way, we see these like patterns that come about of students, they constantly do the same things over and over, despite us how we model them, like they don't follow exactly how we set out our answers and things like that. So what I want to focus on today is I actually want to focus on like general techniques for your exam. So this is assuming you know your content already, right? This is not a lesson about how to learn things or if you don't know how to answer the question, that's not what this lesson is about. It's about how to answer the question given that you know what you want to do. Because the last thing that you want to do is know how to do a problem, but then set it out in a way where you lose marks, okay? Right? So that's what I want to talk about today. And I'll start off with this example. These examples are not on your sheet, okay? But this is a bit about what I'm talking about. Have a look at this here. This is my first solution to this. Now, just as a hint, everything that's in red there's something not quite right with it, okay? So let me know if you can see what's not quite right with this first solution. This is the question over here. Differentiate x to the 4 plus 5x to the minus 1, right? The answer itself is actually correct. Right, but can anyone tell me what's not quite right with the solution setting out? Oh, the solution is actually not right. There should be a cubed here. Sorry. That was actually my mistake. Actually, you know what? We should do that in green because we're fixing that. So there we go. Why is it equals weird, Harry? It doesn't equal that. Like f of x doesn't equal to f dash of x. Why do you think they might have written it like that though? It's like a train of thought. It's like when you write in English, you write across the page, you write like a sentence, right? Mathematical sentences work differently. We write down the page. So this is the first issue. You need to write down the page, yeah? Yeah. What's wrong? Yeah, all good? Right? So the first thing is you write down the page. And time again, in your exams, I've been seeing that, and I've been saying it lots and lots of times, but I think until you actually see, so rather than me just telling you, until you actually see it written down, what it actually looks like, you actually notice yourself, like why that looks a bit weird, right? Because it doesn't really make sense the way we've written it like that. The other issue is what Harry picked up on as well. It wasn't just that they're writing across the page that's wrong, right? It's that this is not actually equal to this. And a common mistake that students do with their setting out is they use the equal sign as like a next step. Like this is the next thing I'm going to do, which I kind of understand. If you really need to do that, like you might want to add like an arrow or something like that, but even then that's not good because we're not writing down the page anymore. So really, right, that's the other issue that's there, right? We need to be making sure that equals means the same. Now that may seem really obvious, yeah, but again, this is something that we commonly see that they use equals as like a next step, yeah. So if I was to write this out, properly, what we would say is f of x is equal to x to the 4 plus 5x to the minus 1. And so we're writing down the page now. F dash of x is equal to this. You don't have to write out the solutions yourselves. That's okay. Because I'm going to move pretty quickly through these. But I will give you a copy of these later. All right. So that's the first thing. Making sure you're writing down the page and use equals for things that are identical. They have to be the same. Okay? All right, here's the next one. Again, this one's not on your sheet. But here's our question. Find the gradient of the tangent to the curve at the point where x is equal to 2. So here's our first solution. Anyone see any issues with this one? So find the gradient of the tangent to the curve.
They haven't substituted 2.
They haven't substituted 2. What have they actually done though? So that's what the first thing Christian knows. They haven't substituted 2, which is what we want to do. What have they done instead? They've differentiated correctly, yeah?
They made the derivative like equal 0.
Yeah.
That's still a bit.
Yeah, why have they done that? When do you usually let the derivative equal to 0?
When it's a full curve.
Yeah, when you're trying to find, what did you do in your other stationary points, right? Where's the word stationary point here? There is none, right? But the issue with in mathematics is that you follow a lot of processes over and over again, right? And anytime people see the word tangent, they actually just think, oh, it's probably like a stationary point question or gradient or something like that. They just think, yep, let y dash equal to 0, boom, boom, boom. The other issue is they actually haven't even written that, right? They haven't written, let y dash equal to 0 or something like that. And even then, they haven't actually solved it properly because, students a lot of the time, they'll see, if they have an equation like this, 0 is equal to 1 on x, they'll just say, yeah, x is equal to 0 or something like that. They'll make up some algebra, which actually isn't quite true, right? Because this actually has no solutions here, okay? Right? So there's a few issues here. First of all, the first issue is they haven't no explanation of their solutions, right? So if you are doing something, you should almost always write what you're actually doing, right? If you're going to let y dash equal to 0, write let y dash equal to 0. Don't just assume that the marker is going to automatically know what you're talking about, right? Because what you think is clear and makes sense doesn't always make sense to other people. And hopefully this is a clear way of showing you that. Because when you read through this, it doesn't really make sense, right? So that's why these steps should be very clear. No explanation of solutions. Honestly, read the question, right? Time and time again, we see people going through this and they're not actually reading the question. All they're doing is they're seeing tangent and they just let y dash equal to 0. They're doing something silly, right? Also, on the note of reading the question, this says find the gradient. What do you think a lot of students might do? They might go a bit extra. They might do an extra step. What do you think they might do? Not find the gradient itself. They might find something else. Find the equation of the line, right? So actually read the question and answer the question you're trying to find, because a lot of students might just find the equation of the line. That's not wrong, but they're not answering the question. They're doing more work than they need to, okay? This one over here. And this is what I was talking about, right? Like this is differentiated correctly, but then what have they done in this next step? Yeah.
They skipped a step.
Yeah, well, again, it's like, what's skipping a step, right? Like, they did what you suggested earlier. They said, what did they say? They let, yeah, they add x equals to 2, or let x equals to 2, right? But they haven't written that, right? And it's just little things like that that turn your solution from mediocre to good, right? Like, this is probably a better solution.
So
Yeah.
those haven't really shown how to get to, they haven't really differentiated.
Yeah, well, they've probably skipped a step here. They've probably done this, right? I'm okay with you skipping that step. That's okay in my perspective, okay? But if we're talking about explanation of solutions, what you might want to do is, for the gradient, find y dash or find dy dx, okay? Right? That may seem excessive, but again, I'm talking about what's a good solution here, right? And this is assuming you actually know all this stuff as well, right? So this is stuff you want to focus on once you know your content as well, right? Okay, this is the one I really love. This is a classic. What kind of question is this? Show, proof, right? And first line already. Yes, what have I done, Harry? Both sides, okay? In a proof, here's the first mistake. Write this down with me. Never start with both sides in a proof question. And I understand why students do it, right? I understand why students do it. Because in the question, it just says this. It says this, right? But whenever you're writing a proof question, you should always be going from left to right. So instead, always go from left-hand side to right-hand side, or right-hand side to left-hand side, doesn't matter, right? But the way you should be writing it out is like, the left-hand side equals to this, and then it equals to something else, and then it equals to something else, and hopefully at the end, it equals to the right-hand side. That's what you really want to be doing here with that, yeah? Okay? So that's the kind of main issue that's here, right? This is actually correct in terms of the algebra that they've done, yeah? But the issue that they have is that they haven't actually written out in the correct way, okay? The left-hand side is equal to the right-hand side, but you can't start with both sides and manipulate it in that way. You always have to be going from left-hand side to right-hand side, yeah? Does that make sense, sir? Yeah? Cool. And I mean, along the lines of that, never assume, like if they ask you to prove or show something, you can never assume that. That's kind of why you should never write with two sides there. Because you're assuming, remember what I said about equals, right? You're saying that this is equal to this, but they're asking you to prove that. That's actually the question that they're trying to get you to do, okay? Next one, again, one of my favorites, and I'm glad to see that not everyone has made that mistake now. Can anyone see the first mistake here? They cancelled out x, right? And typically cancelling, is okay when it's fine with numbers, right? If you have, like before in the question, we had 3 on 3x. What you do is you cancel out 3's, and that becomes 1 on x, yeah? But the issue with doing that with letters, with variables, is you actually lose solutions. So here's my next tip. Never divide by a variable. So what they've actually done is they've divided both sides by x here, right? They've divided both sides by x because there's an x squared and there's a factor of xs, so they divide both and they get x equals 4. Now that's actually a correct solution. If you substitute back into it, it actually works, right? But the issue is you lose solutions. Yeah? You lose solutions, right? So we won't divide by x. Here's my second solution. What have they forgotten here? Luan, have a look at this one. You actually, can you see anything that's missing with this one over here? What have they done? Like, what have they tried to do? Good, okay. So the first thing is that they're trying to take the square root of both sides. So when people take the square root of both sides, they always forget to do the positive and negative cases, right? So they always forget the positive and negative cases with square roots. Right? So let's fix that up there. But can anyone else see another mistake with this one? They have x's on both sides, right? So a common mistake with something like this is that they think, yeah, okay, I remember the positive and negative case, but this is actually not going to help you solve anything, right? Because anytime you have a quadratic, right, pretty much almost always, you want to put them on the same side so you can actually solve for them, right? So what do I mean by putting them on the same side? Well, what should really, if this is my question here, what should my first line really be? Good. X squared minus 4x equals 0. Keep going for me, Harry. And then you factorize, right? So anytime you have quadratics, you factorize. And so x is equal to 0 or 4. So the solution, the fix for something like this, is that instead of actually dividing or instead of taking the square root of both sides, you factorize. So the solution is to factorize. Factorize instead. Okay? I think that's all we have time for right now because you've got an assembly. But we will continue on with the next question afterwards. You can have a go at those questions and see if you can spot the mistakes that students might make with something like that.